This is episode 13 of Soundproofeth, and my name is Carrie.
And this is Phil.
Today, we're talking to an acoustician and self-confessed noise hunter named Nathan Sibon. He works on some large projects, mostly in the San Francisco Bay Area. And we were curious to know, what does he do exactly? And also, his thoughts on some common noise problems that show up in buildings.
So I think the best way to describe my job, usually when I'm talking to people that have no idea, like I meet a new friend or something like that, and they don't understand what acoustics is. Usually if you say the word acoustics, they kind of give you a blank look, or they get really excited because they think you record music, which, so usually I tell them my job is to make noise go away. But if I, just to speak more generally, I think I help other people understand a problem they're facing and what their options might be. And I kind of just like walk them through that process. That's really as a consultant specifically, like that's what our job is. Most of the time, each project is unique and each problem is like slightly unique. The general kind of issues and solutions are pretty similar.
So are these home designs or office building designs or what specifically?
Yeah, we do. Man, I've been on all sorts of things. I'm working on a really nice single family house in San Francisco right now. I mean, really nice. But we work on, office design. We work on laboratories. I was doing a medical facility in South America a couple of years ago. It's usually in the building industry, but pretty much anytime you're building something, there's firms that focus exclusively on transportation. So let's say you're building the California high-speed rail. I have a friend that works for a firm in the East Bay. They were doing the noise studies for the high-speed rail. So they were measuring noise and vibration all up and down this kind of corridor in California to understand what the existing noise is. And, when we put in this train, how is that going to change? And do we need to protect certain areas because they're, a residential home? Or can we move this thing somewhere else to mitigate the noise?
Just a guess, is the company Wilson Erig that's doing that noise study?
Yeah, Wilson Erig. They're involved in part of it, I think. It's such a huge project. I seriously doubt that just one firm is doing all of it.
So I guess I have a few questions about that. At what point in the process is an acoustician consulted in a building process? And is this like a requirement because they're forced to do this because of standards? Or is it like a quality thing that if you want a really nice facility, they have certain needs, or it's desirable to have the noise abatement?
Right. So it used to be like a pretty rare specialty, but in the last probably 50 years, people have started to catch on to, people are sensitive to noise and people want speech privacy. People want this acoustic comfort. They don't want to be blasted by noise from their air conditioning systems. So I think the desire has definitely ramped up in the last 50 years, and that has kind of like helped us become more part of the process. In California in the 1970s, kind of following all of the noise control legislation on the federal side, they introduced the acoustic requirements into the Title 24 regulations. So when you're building housing, or I shouldn't say housing, anywhere where a human is going to sleep in California, there are certain requirements that you have to build the outside of the building to make sure that they're not going to, be blasted by traffic noise. And so that they can sleep comfortably. That includes everything from like, just a person's home to senior care facilities, hospitals, things like that. So there are codes that people are held to in California specifically, not so much in the rest of the country, which is unfortunate. We don't actually have a federal legislation, but there are certain, if you're getting federal funding for certain types of projects, like HUD has standards. So it's kind of a mix on projects, whether you're going to have an acoustical consultant or not. Like if you're renovating your office, you may not have someone on your project because the architect either one, it wasn't required in their contract, or two, the architect, their contractor thinks they can get away without it. They're like, oh, we do this all the time, it's fine. But I think a lot of companies in the Bay Area, at least a lot of the larger tech and biotech companies are starting to write internal standards for everything from acoustics to lighting to air quality. They say, you know what, every time we build a project, here's what you have to do. And so now I think Office has always kind of had an acoustical consultant in the last probably, I mean, I've been doing this for 5-6 years now. So yeah, I can't speak to 20 years, but just the general feel of the industry feels like they were on those projects because we talk a lot about office acoustics in the literature. But yeah, it's starting to become more required. And like solving any issue, the earlier the better, because
Well, that's much better than trying to fix acoustical issues after everything is built.
Yeah, absolutely. I mean, retrofits, when it's for an acoustic issue, it's never a cheap thing just because of, now you're having to work around all this existing stuff. But not only that, but most of the time, to truly solve an acoustic issue, we're not putting up a few panels or, putting some like a neoprene pad or something like that somewhere. There we're talking like real construction. Unfortunately, and so as soon as you start ripping drywall out, it's game over for a lot of people's budgets, which I think is what makes this super frustrating for apartment and condo dwellers. Is it's not feasible for them to take it on their own, and if it's not there in the original design, it's you're just kind of stuck with it.
I'm one of those apartment dwellers, and I've tried to fix some of the issues. My apartment was built in the 1950s, and it wasn't a great time period for acoustical issues.
Yep. Pre-Title 24.
The standards got much better later.
So Title 24 has a lot of regulations in it, but in the 70s, I know, is when they introduced the acoustic requirements. So if you find a place that was built post mid-1970s, most likely they had to meet a sort of minimum standard for transmission between common walls. And I don't know if they included, there's a metric for like how well your floor system absorbs the noise from you walking around on it to the person below. I don't remember if that was in the original, but that's another big one in residential construction. So if you can, the newer places are to a certain extent better.
Yeah. For example, I think the hardwood floors in my place were just nailed right onto the wooden joists. No underlayment, so walking on the floors is like beating a drum. And the walls were completely hollow with no insulation. The exterior of the building is stucco. So how does that compare to other exteriors?
Yeah, so when we talk about sound transmission, like through a material, one of the main things we're looking for is mass. And actually, stucco is fairly good compared to other common building materials because stucco is essentially like a really lightweight concrete. It's a really thin application, but it's still, a concrete type material. The Canadians are actually really good about, their government has funded a lot of really great acoustic testing, the CNRC. They've done really, really great extensive testing on a lot of single family home style construction materials. And compared to things like siding and, a wood exterior, or even in modern buildings, the kind of thin metal panel that's really popular right now and all of these new multifamily things, stucco's pretty good. The insulation is probably your killer there. If you don't have insulation in the gate, when we talk about sound transmission, insulation's just like a basic requirement. We don't even talk about it if it's not there.
Oh, yeah. I blew cellulose into my walls, and that really helped a lot.
Well, I was just wondering, from a theoretical perspective, what would be an ideal wall? Or is this a geometry and a material thing? I assume are both important, but if we were to create a completely, a Faraday cage for acoustics that would completely block out sound, at least from one direction, does that make sense? Like an idealized wall?
Yeah. So the first thing you got to define in any acoustic problem is like, what's the range of frequencies you're interested in? Because I can build you could build a wall that mops up most of the perceivable noise at 2000 hertz, no problem. It's an easy thing to do. Well, maybe I shouldn't say 2000. Let's say 1000. There's an interesting resonance at 2000 hertz in most drywall partitions. So that's a different story. So 1000 hertz, super easy. If you were to say to me, I have a noise problem at 50 hertz and I want to completely get rid of all the noise, that's going to be a more challenging problem. And of course, this all depends on the level of the source. In acoustics, like when we think about any problem, we go back to this really, really basic model called source path receiver. Because if you think about any acoustic problem this way, it's much easier to kind of understand what your options are. Because usually there's a little bit or a lot that you can do in one of these three things that will help solve your issue. So if your source is kind of, let's say, we're talking about my house, and this is my living room, and I want to play my music. So I'm not going to blast that noise at 100 dBA because I'm not going to enjoy that because I'm 6 feet away from it. Let's say it's something reasonable, something in the 70s. So I can hear it just fine. There's no issue with like signal to noise, and I'm enjoying it. But it's at a level that I don't know if you guys have heard of the rock threshold. There's this perceptual effect that they've measured in psychoacoustics that when you turn up music past certain thresholds, your enjoyment of it increases a lot. So people like to listen to music loud, setting that up as our source. I could certainly solve my noise control problem by turning the music down. Is that if it's pissing off my neighbor? If it's maybe I don't want to turn it down, and maybe I think that there's a way to do it without turning it down. So source is set. We move on to the path. The path of the sound from my speakers is through the air. So now we're talking about the airborne transmission loss through the partition itself. And it's really important to define how the sound is traveling because the solutions are incredibly different when you're talking about structure-borne noise. So for airborne, when we look at transmission loss through a partition, we're looking at mass, and we're looking at if you have more than one layer, how are those layers decoupled? So if I was going to build you a perfect wall for my apartment, just theoretically speaking, and I wanted to play my music through my normal speakers, so we're talking probably 60 hertz to 480K, I would love to have two independent walls, both built of CMU, concrete masonry units, and filled with concrete, and the cavity between them was, a good couple feet full of insulation. That would be the theoretically ideal wall for that. And I could probably turn my music up almost as loud as I wanted, so long as, the floor and ceiling and the other possible paths were not allowing noise to flank. That's a whole different issue. Is it practical to build two independent CMU walls with a couple feet of airspace in between them in an apartment? Absolutely not. That's really where the issue always comes down to, is like there's all these great theoretical separations and solutions, but there's so few of them that are practical. The weight alone from that wall would probably just collapse the structure of my building.
So staying in the theoretical space, I mean, from a material perspective, could there be some carbon nanofiber material that doesn't can the material overcome some of those geometrical things?
So I think what you're kind of getting at is like mass is the basic model, but there are other things we can do, because there's a lot of products out there now that are, not just adding mass, they're doing something else, and they're claiming some kind of help with sound transmission. Like, oh God, there's so many. Green glue comes to mind. So mass and stiffness are the basic models. When we talk simply about sound transmission, I'm looking for mass as a basic thing. If we don't have mass, then we want to just decouple. multiple layers of mass. Because if you combine all of those layers together and they work together acoustically, whether that's because they're close together in their airspace or if they're physically connected by like a stud or something like that, then they're going to work together and they won't act independently as two different barriers. There are materials that have different properties that can help, but I always like to think of solving these issues as kind of like orders of magnitude helping. If adding a product is going to give me a few dB and I have to spend, hours retrofitting and, $500 to do it, I'm not going to chase those few dB. And in a lot of cases, that's what, there are no magic products right now. I'll just put it that way. That's your question on it. Things like green glue, those are working on a principle called constrained layer damping, which basically just means if you have two pieces of mass, can we put a damping material in between that basically gets rid of the resonance that happens from the interaction between these two layers. And with that, if you guys want to get into the weeds, we're just getting rid of a few of these small deficiencies. If you were to look at the transmission loss over frequency of your overall system, we're just getting rid of a few of these little deficiencies. So your gain overall is somewhat limited. I had a friend who was retrofitting his house and actually told him not to use green glue. It probably wasn't I was like, you could do that if you want, but I don't think you're going to get anything worth it out of it.
So actually, I've used green glue on some of my walls, and I think it helped a lot. I wouldn't use it for ceilings in a multi-unit building because I think that it needs a different solution. With the impact noise coming from a floor, I don't think it's the right solution for a ceiling. However, if you use green glue and, with a second layer of drywall glued over an existing wall with insulation, and without having to tear off the existing wall, I think that helped a lot. However, the point of failure now is the window. The window assembly is the problem now.
Oh, yeah.
It's not the wall. So, I think I read that green glue takes noise and transfers it to heat.
Yeah, I mean, that's how all of these things work. That's not unique to green glue. When we talk about sound absorption in a room, you have something fuzzy, like your couch or an acoustic panel or something. When the wave hits that material, it's basically just slowing it down. Like you've seen the airport when planes go out of control, there's those pads of material they can just essentially plow into and it slows them down. That's like a really large scale version of what is going on. So it's dissipating all of that extra energy. We're doing a very similar thing, just turning it into heat. So I'm curious, when you did that retrofit, did you do both the green glue and the insulation at the same time?
I did the blow-in insulation first. There's a local company that can come out and poke holes in your walls, and they blow the insulation in. And then a big new building started, a new construction project. A big new building got built right behind my apartment. And so I added the new layer of wall for extra density and more sound control. And I decided to use Quiet Rock drywall to get extra dampening along with a green glue.
It's exactly the same as green glue. They work on the exact same principle, and Quiet Rock is just green glue you don't have to put in yourself.
And eventually, we put in a suspended ceiling in the bedroom in the apartment below mine because the original ceiling was hollow and it was just nailed to the joist. So you could hear everything. I was being kept awake by snoring and talking and, So we hired someone to tear off the old ceiling, and we put in a new one with insulation and a layer of mass-loaded vinyl. And then the new ceiling was more than just one layer of drywall. It had a couple of layers and a green glue-like substance in between those layers. And it was decoupled from the joist by using those metal resilient channels that run perpendicular to the joist. And you attach the drywall to those channels and not to the joist. And this solution totally took care of the snoring and the talking.
Yeah, there's a lot of options, and a lot of the issue is kind of helping people navigate this big open ocean of what they could do.
But you know what? It didn't eliminate the impact noise coming from downstairs. I could still hear the neighbors walking around underneath me and opening and closing their dresser drawers.
There's a lot of, I think one of the real challenges with acoustics, and well, it keeps me, employed. It's kind of frustrating to go on the internet, you go on forums, you go on YouTube videos. There's a couple prominent contractors that have a couple videos about, what you can do about sound transmission. And there's a lot of misinformation and kind of misinterpretation of a lot of the data. And it's frustrating for me. I see it and I just, get red in the face and I'm like, no, that's not how that works. So the acoustic community is working on, bettering standards and helping consumers make better decisions. I think one of the issues right now is when we're talking about sound transmission, and even when we're not talking about sound transmission, unfortunately, there's products that have nothing to do with sound transmission that are putting an STC performance on their product. I think it's really important for people to understand what the metric that is being claimed is based on. Like STC is like trying to sum up a very complicated problem, which is, sound transmission over these many frequencies into a single number that you can compare apples to apples, hopefully. But if you were to go in and you were to dig into the individual transmission loss results in the individual third octave bands, look at the spectrum, you'll see things with the same STC but wildly different spectrums. So it's not an end-all be-all. I think people need to understand that, like, that metric specifically, since we're talking about apartment to apartment transmission, that was developed to describe transmission as it relates to speech and nothing else. So if your problem is not human speech, that's the wrong metric. And that's part of our issue is we don't have another one. There's no metric for, my problem is my neighbor's stereo. When we're talking about music playback and you have a lot of low frequency content, SDC is more or less meaningless because an improvement of 5 to 10 SDC points in a product could relate to fixing some of these high frequency resonances at 1, 2K. But when you hear music coming from your neighbors, are you annoyed by the cymbals or are you annoyed by the bass? It's the bass.
And it's hard to measure, isn't it?
Right. So STC and noise are going to be kind of opposites. It's like golf. The higher STC, the better it is at transmission, and the lower your sound level is going to be. Yeah. And that's what I think is so acoustics, I think, in principle, acoustics is very easy. Like I tell people they ask me, what's the best thing you can do for noise control? And my answer is don't put the loud thing next to the quiet place. Everybody understands that. And, if you go to community meetings for new projects, like people understand acoustics to some degree. Like as long as we're not talking about numbers, it's a very easy problem because people understand it intuitively. We've lived with sound our entire lives. Like even from before we were born, we were hearing stuff when we were in the womb past a certain point. So we know sound as humans. The problem is as soon as you want to put a number to that, the physics and the math and, all the things that come with modern measuring equipment, that problem is incredibly complex. And, even us in the community, we're learning every day as you get more experience and, college can only teach you so much. As soon as you want to put numbers to it, it becomes an incredibly complex problem that I think would be really, really challenging for your average person to understand, especially without a theoretical background. Like I think it's probably a frustrating experience to have an issue and to go online and search for information because you might find this forum of Gear Sluts comes to mind. There are a bunch of audio people and, there's a lot of really interesting ideas on those forums. Sometimes I read them for fun.
The pro audio community is rife with, rules of thumb and misinformation, I think.
Yeah.
Well, so I wonder, so the STC measurement is adapted for speech, or it's that's what it's measuring. So I wonder, would it be helpful, do you think, or maybe there's another method, like to have another measurement that's like, this is specifically for traffic noise, where like the tires have a certain peak frequency, the tire noise and the engine noise, like have a variety of measurements for common issues that then you could rate a product on. Maybe that ends up being a lot of bureaucratic paperwork and it's not a efficient method, but do you think that there is a way to organize that from a consumer perspective for like different products, like rating it on these different noise problems?
Yeah, absolutely. And it's interesting that you picked traffic, because that is one of the few, and off the top of my head, only other sort of source dependent single number metrics that exists. It's called OITC. It's the Outdoor Indoor Sound Transmission Class. And what they did is, instead of taking speech as your kind of frequency that or your spectrum that you use to rate a material, they've developed a composite spectrum that accounts for normal car traffic, trucks, buses, airplanes, rail. And it doesn't do all of them perfectly, but it's tried to take this really complicated, varying spectrum that is transportation noise and distill it down into a spectrum that we can use to compare windows to windows and walls to windows. Because unfortunately, there's still a lot of consultants out there that I see reports from that say your windows need to be STC 37, and STC is just meaningless when we talk about traffic noise. You're basically taking a really good guess. And there's a metric that was developed, and it's been out for a long time. We just don't see it very much because a lot of people don't. A lot of people aren't retrofitting their own windows.
Well, we did it. We had single pane aluminum windows in my building, and we retrofitted them with vinyl windows with double pane glass. And I was expecting it to be a lot more effective. It helped a little, but if a truck or motorcycle drives by, it just sounds like the windows are open.
And I think windows are challenging because, like, if we go back to those basics, a couple small layers of glass very close together, it's not a lot of mass and it's not a lot of separation. There's just physical limitations. We can't change the laws of physics, unfortunately. And you can do laminated glass, but again, laminated glass is working on the same it's the same principle as the drywall products we were talking about earlier. It's constrained layer damping. It's getting rid of a couple key resonances in the high frequencies, but it's not doing much more than that. So, and when we think about this in terms of that basic model source path receiver, when we're talking about a garbage truck or a motorcycle, the source is just so loud that there's, even if we could get better windows, you're probably still going to hear it. It's just a really, really loud source, and it's unfortunate.
And I think oftentimes the motorcycles are actually not even street legal in the volume that they at least in Berkeley and in Oakland, where there are like noise ordinances, a lot of those vehicles are just not legal in that sense. I guess that's a different issue, though. I've being a musician, I have received noise complaints, and talking to people in the know, some housing authority people, they basically told me in order to actually be prosecuted for any of this, a police officer would have to witness me creating the noise and simultaneously measure it to prove that I was breaking it. So there's not an easy way of recourse for dealing with these, from like removing bad actors either.
Yeah, it's frustrating. And even just talking about the traffic in general, the regulations around that are really challenging. Yes, there's plenty of cars going around with improper mufflers and they're way too loud, but do we really want, I am sensitive to noise issues, and I want to solve all the problems of the world. So I would like those people to be caught and prosecuted, but do I want to do that at the expense of the other problems in San Francisco right now? I don't know. I kind of put it as a toss up, because I know that, yeah, well, the motorcycles are annoying. There's probably plenty of motorcycles within regulation that I would find annoying too. When you break down the problem to its really simple fundamentals, it's a motorcycle. It's going to be loud.
Right. Right. Yeah, I think it's true. And I should probably have more empathy, because when I play music, I think I'm, giving a beautiful gift to the world, and my neighbors disagree.
Right. And that's one of the first things we think about in noise control is like, because the difference between noise and sound is different to everyone that you ask, because it's whether you want it or not. That's the only thing that differentiates noise versus sound. Phil, if your neighbors like your music, it's suddenly not noise, it's sound. And they go, oh, cool, Phil's giving us a little concert through the walls again. But, let's say they hate the kind of music you play for whatever reason. Suddenly it's noise. And it's a really challenging problem to try and distill into a couple pieces of legislation and a couple numbers that we can hold people to.
So let's say you live in an older apartment and you have some typical noise issues. You've got traffic noise, you've got interior noise, like maybe your neighbor has a toddler running around upstairs.
Yikes.
And you notice it more because everyone's home right now. But you have a limited budget. So without completely tearing your house apart, what are some of the things you can do?
Yeah, and I think if we look back at that basic source path receiver model, the receiver is the part that you can do the most about without doing construction. And what I mean by that is, and unfortunately, it's the answer nobody wants to hear. It's change the way you're interacting with your environment. You are the thing, if you're annoyed, you're the thing that can be changed the most in most situations. So if you have, let's say you have like a 1-bedroom apartment with an open living area, and your neighbor likes to play music every day at 2 p.m., you hate their music, go in the other room, close the door. It's honestly the best thing you can do. I think if you want to talk about ways that you can modify the middle part, which I think is what people look for when they Google these things all the time, they're looking for, what can I do in the path? Can I, add something to the wall? I see all sorts of crazy stuff, like people say, put bookshelves against the wall and I just don't even know how to respond to that.
Or put egg cartons up, which also doesn't help. I think a lot of people don't know the difference between changing how the noise is absorbed in your home, the noise that you make, and the noise that's coming in from the outside of your home. I'm surprised at some of the things I see online too. Like on Amazon, they promote heavy blackout drapes that are supposedly soundproof. I think that's impossible. Putting drapes on your windows isn't going to block traffic noise.
And it's a super common confusion, and honestly, it's a really reasonable one. The term is sound absorption, so obviously, if the sound has to pass through it, doesn't it get absorbed? Like it honestly is. When I was studying acoustics in college, I had all of the equations and the physics and the math and the test data in front of me, and I would still think to myself every once in a while at night when it was quiet, which was rare in my college dorm, being right next to the heat pump closet. I was like, but why? It sounds like it should make sense. It took me a while, and so it's a super reasonable thing, but it's probably the biggest myth in noise control is sound absorption does not equal preventing sound from getting to you. And I was looking through some old HUD documents a couple months ago on noise control, and these are from 60s and 70s, something back then, maybe the 80s. They're old. And they even call out right away, first few pages of the document talking about noise control. There's this great, I should find it, send it to you. There's this great sentence that says something about noise control. You can't solve this problem by putting sound absorptive panels on the wall. And to do so would be a waste of time and money or something really blunt. I printed that out and I put it on my desk.
Well, sound panels do help absorb noise in situations like a crowded restaurant, internal noise. Not everyone can afford a whole system like from Meyer Sound.
I guess it occurs to me too that there's an altruistic approach, at least in apartment buildings, where maybe just an awareness of you have downstairs neighbors, so don't tap dancing clogs. You realizing that you are the source of noise
Yeah.
and how you can, mitigate those things. But it's kind of like there's the tragedy of the commons as well in that, like, that's the gamble, I guess.
It's such a challenging thing to realize too. We're such visual creatures, unfortunately. We're very auditory creatures, but in our culture, we've become very visual. Since you're in this visual box where your sight is contained, you don't see the other people and you kind of forget about them, or you think, what I'm doing is fine because you don't see those reactions from people. If you were in the same room as somebody who was trying to do their homework and you got up and started doing jumping jacks and tap shoes, like, they would look at you and be like, what are you doing? I'm trying to study here. But you don't get that in an apartment building where there's a couple layers of drywall between you and the other person. So it's a super easy thing to forget about. But I think it's that's the other thing you can do, besides if you're the source of the problem, or if you have a good relationship with your neighbors, or you can cultivate one, talking to them and trying to find some reasonable compromise is the best thing that you can do. Because without doing major construction, the improvements you can get in that path part of the model are incredibly limited, and you can get so much more by changing the source or the receiver. If you can get your neighbor to turn down their music, unfortunately, people have this perception that I paid for this place, I'm going to do whatever I want in it. America. And it's just not reasonable. And if you're in a single family house, you could do some of that, but you still get noise complaints from somebody banging on the drums for 10 hours a day in a residential neighborhood. There's just certain things you unfortunately can't do. When we've been stuck inside, we've been trying to stay sane and keep active, so we've been doing a lot of those exercise videos people are posting on Instagram. And there's this one hosted by a couple in LA, and they've been doing it lately where part of it will be jumping jacks. I'm on the third floor of a multifamily building, and that I know is wood frame, and I know is not very good acoustically. I don't do the jumping jacks. I just found some alternative that doesn't require me landing all 145 pounds of me on this poor structure.
I had this slamming issue with my downstairs neighbors. They would slam their kitchen cabinets so hard that it sounded like there was a demolition crew downstairs.
Right.
And they like to cook at home, so I heard this loud smashing and banging every day in my apartment. So finally I gave them some felt bumpers to put on the inside of their cabinet doors just to soften the slamming. They never used them. Basically, they treated me like I was a complainer and a nuisance. So I tried to modify some things in my kitchen to reduce their slamming noises, but nothing really worked. And finally, when they moved out, I saw the inside of their cabinets. They'd put these clasps on the inside of the doors, like some kind of earthquake safety clasps. So no wonder why I heard so much slamming. It actually took brute force to get the cabinets opened and closed. So either they were somehow unaware or they just didn't care.
Yeah, and I think with the cabinets specifically, there's a couple things you can do, and I would almost encourage you to start with having the neighbor change their habits. The pads are great, honestly. For cabinets, soft closers are better, because you still, even with the pads, you've still got this same mass at the same acceleration going, and there's only so much you can do. If you can slow down the cabinet moving, literally, that's doing a lot better. One of the things I've found is there's this perception when somebody is given some tool to solve a problem that is not changing the behavior. There's almost this idea that they have that, oh, well, this thing is doing all the work. That solved the problem, and now I can just keep living my life the way that I always normally do. And if you could totally have a situation where a neighbor has loud cabinets, you give them the pads, and they go, cool, put the pads in, slam. They don't think about it. And a lot of people, I think the people that are malicious about it, those are the rarity. I think a lot of people just, if they're not there to experience it, they don't believe or understand. I had a friend who was in an apartment somewhere on the east side of the city, and their bedroom, it was not a mirrored layout. So you didn't have bedrooms on bedrooms. Her neighbor's kitchen was above her bedroom, which is super unfortunate. And, there was all the young people in the building. So, they had a couple 20 something dudes that would come home from a night out on Polk Street, and they would, be making the last nachos of the night in the kitchen, stomping around. And it's an old building, so it's a really flimsy, lightweight structure, no considerations for sound. And my friend had complained to the landlord, and they were like, I don't know what you're talking about. That's never been a problem before. You're the first person. Never been a problem before is my loathed phrase, because people say it for everything. But it wasn't until she moved out and new neighbors moved in, had the same issue, and the landlord came over and heard it. They had her son go walk around in the kitchen in a very normal way, like they weren't stomping. It was just a casual walking. And they ended up emailing her later saying, like, oh my God, we're so sorry. We didn't realize that this was actually a problem. We just experienced it for ourselves. So sometimes getting that, we'll call them an offender, even though it's probably not a great term, getting them to experience what you're experiencing, that will, in most cases, turn what was an enemy before into a friend, because most people are reasonable. They'll say, oh God, I would hate to live with that. Let's work something out.
With my upstairs neighbor currently, we have a tense relationship, but I would very much like to just observe their apartment to see where they are working in what room, so that I could then move my annoying noise generation into, the furthest corner away from them. Or like, it's not clear to me if the room I'm in now is more annoying than if I hid in the bathroom or in the kitchen, like, and depending on where they are. It's a very old building, and also there's a Chinese restaurant beneath me. So I can stomp all I want, but they make a lot of noise when they turn on their flume or oven or whatever.
And for apartment dwellers, that's my other major suggestion for noise control. If it's something you can't live with, move. Unfortunately, we did that a couple of years ago. I used to live right on Lincoln Avenue in an old early 1900s building with early 1900s windows, and the traffic noise was unbearable. I don't know how anybody lives on that street with those old windows. And financially and with where we were in our lives, we couldn't just pick up and move 2 days later. We actually ended up taking that apartment kind of under duress because another one fell through. And I dealt with it for a few years, and it was awful. And then we moved, and that solved the problem. Now I'm on a backside apartment near the park near Standian, and it's so much quieter. There's no traffic noise. If we have more modern windows, but when we open them, you hear it. But because I have that sense of control over it, it's not a problem for me. And it's tough because people can't just pick up and move every day.
So what about window inserts?
So I actually looked into those at our old place, because I was like, we've got to do something. And the cost alone kind of set me off. We didn't pursue it at all, because just to start, I was like, okay, let's just protect the bedroom. It's 2 windows. It can't be that bad. It would be worth it. It was already north of $500 without shipping. And I just decided, you know what? I'd rather just save that money and just suck it up for a few years and move someplace quieter.
Especially if you don't own it. Yeah, why would you want to spend all that?
Right. If you do own, I don't have any personal experience with them, but as long as the window is your problem, and what I mean by that is that you don't have some leak somewhere else, and you can do all of them at the same time, that's going to be the issue. Is I think some people will think, well, let's just do half the windows because then we'll get, halfway there. But unfortunately, like, I like to think of, when we're talking about sound transmission, I like to think of it kind of like a bucket. If you have a bucket of water made of the thickest gauge steel you can get, it weighs 500 pounds, just carry a gallon of water, but you have one little hole. you're still going to have a water leak. So you have to do all your windows or none of your windows, unfortunately. And that's where, if you have a living room with, many square feet.
You're right about the leaky bucket and flanking noise, too. So you soundproof the wall between your apartment and your neighbor, but now the noise is coming through the ceiling or the vent.
It's good to separate what is it about the noise that's annoying you? Is it's a constant noise that's interfering with my conversations, or is it something that appears and goes away, and just the distraction of hearing that is what is annoying? That's what it was for me with the cars. I mean, there was the constant noise, which was annoying in our living room because, it would mask things like anything I was trying to do. We couldn't hear each other without yelling. If one of us was in the kitchen and the other was in the living room or something, because it was just so loud. But at night, what really got to me was the traffic dies down. And when there is a car, the car is very loud. But compared to the 10, 20 seconds of no cars when there's a red light on Lincoln, it's dead quiet. And suddenly you go from dead quiet to very noticeably loud. That perception change really triggers a lot of it triggers sometimes a fight or flight response in humans. And your stress levels will go up. That's what got to me. So one of the things I was thinking about doing in my old bedroom was, okay, so at night when we're going to go to sleep, what if I can smooth out that transfer? What if I can bring up the background noise so that the change from quiet to traffic that happens every 30 seconds or so doesn't trigger me to pay attention to it and stress me out? Unfortunately, the windows are so bad and the traffic is so loud that by the time I moved, I dialed up. I tried what we call sound masking, but it's just pink noise or white noise. By the time I got that to a level to where I wouldn't recognize the cars if I was doing my best to not pay attention, the masking was so loud it was annoying, and I was afraid it was going to make our neighbors angry. So that was an unfortunate, but that's another thing you can try is like, okay, so if your like neighbor is tired of you playing music while they're trying to work, they're not going to like to hear it, but can they work with headphones on? Can you guys work out a time that says, okay, like, a couple days a week at 2 p.m., this is Phil's music time, and like this is the time we've agreed that I'm going to play music. So, can you do something on your end to make that easier on yourself if they know when it's coming? I think a lot of, like the cars, it was the unpredictability of you're just sitting there waiting for it. You're like, when's Phil going to play the next note? When's he going to play the next note? He finished the song. Is he done now? Or do I have to listen to this for another hour?
And that's much more annoying, right? The psychoacoustics literature proves that, right? That like the interval of the interruption can be, because like a steady state is easier for us to ignore, a constant hum in the background, than the like you're saying, the individual cars on Lincoln. I know anecdotally, other masking solutions. I had some relatives staying in an Airbnb in like the Oakland Hills that was a highway was behind it. And next to the bedroom, outside the bedroom window, the owners had installed a water fixture, and that combined with the traffic noise basically just made like an ocean, kind of like it masked it enough, because from a distance, depending on your distance, the traffic can almost be like ocean noise, except for like the really powerful low energy of the rumbling trucks, and like it's kind of painful depending on how close you are. But their experience was that they just heard a waterfall and they didn't hear traffic, and
Right.
that was very good for sleeping.
And I think as a homeowner, there's so many great ways that you can just kind of, sometimes the problem is that, and this is going to sound counterintuitive, that it's too quiet. Like, I like how quiet our bedroom it is. It's insanely quiet at night, because it's on the back side of our apartment building. But you can hear there's a fan on our roof that, is just strapped to the roof, and it's an older, and there's a little kind of like low frequency rumbling for it. I've just accepted that the noise in this apartment personally is so much better than the one in the last apartment, and I know personally that there's nothing I can do about that fan. So I have just made it my mantra to accept that noise, because really in the end it doesn't interfere with me doing anything. It doesn't keep me up at night. It's so low. It might be a little bit annoying, but it's not the worst thing. But in that situation, let's say you are sensitive to that and you don't want to hear it, playing some music as you go to sleep with a sleep timer on at a low level, just so you're thinking about that as opposed to the noise. Or run a fan. A fan is most people have a fan, and it's a really cheap, easy way to put a little bit of background noise in your room, and you'd be surprised how much that kind of helps you ignore the things that might annoy you.
I've done that. I play chill out music at a low volume to mask out annoying noise coming from inside or outside my building.
And I think that's really where most of these complaints come down is, it's annoying to me because I don't have control over it. And I would encourage people to even hold off on any of these kind of retrofit things until you've gone through the process of trying to force them. Usually, like if you're in a condo, there's an HOA. Appealing to them is a really good step, and it's obviously going to, the tensions with your neighbor are going to probably increase because now you've kind of formally called them out and now they have to deal with it. But it can be an effective way to force somebody to say, okay, you know what, you're playing you with your subwoofer right on your neighbor's wall. You can't do that if you're going to play it that loudly. They may be able to force them to do something. In an apartment building, it would be your landlord, complaining and saying, hey, these people come home at 3 a.m. and then they play dubstep for another hour and they go to bed. I can't live with that. In San Francisco, there are interior noise limits in residences. But I want to caveat that with saying I've never, ever had a case where I've seen them enforced or measured. I just think people don't have time, unfortunately. So there may be, if it gets to that point, there may be some legal thing you can do, but it's probably not worth it by the time the lawyers get involved.
So what about laundry machine noise? A lot of apartments have laundry machines in them now in multi-unit apartment buildings.
Yikes. So let's just start by saying if it's on the first floor, that's where it should be. And I know most people can't change that, but that's my way of rolling into if it's on an elevated floor, you're on a flexible structure. And if you have an older washing machine that moves a lot, there is no solution, unfortunately. The main issue with washers and dryers is not necessarily the just kind of normal movement of them. It's the spin cycle. And this is exactly like what we talk about when we talk about large equipment for air conditioning and things like that. The issue with vibration is not because the machine is necessarily old and in poor condition. New machines vibrate. The issue is imbalance. So as this thing is spinning, theoretically, if you could make a machine that had all of the rotational forces perfectly in alignment and canceling each other out and balanced, there wouldn't be any vibration. But that's just not physically possible. And a laundry machine is one of the worst offenders because you've got all these clothes that are wet in there and it's just literally throwing them around in a circle. The best thing that new washing machines have done is they've put a lot of R&D into internal sensors and adjustments that they can make to automatically adjust for the load inside and try and balance it to the best of their ability. They've also greatly increased the spin cycle speed so that they can save energy during the drying phase. So they've kind of undone themselves there a little bit. But in terms of what you as a homeowner can do, I see a lot of stuff on Amazon about and a lot of stuff in those YouTube videos about rubber pads and things like that. Is that going to take a little bit of the edge off? Maybe, but it's not going to stop your floor from vibrating. There's too much movement for that piece of rubber to absorb. And besides that, if you're in a wood frame structure, like pretty much all of us probably are, unless you're in a new high rise, the issue isn't even necessarily that this material isn't good enough. Your structure's just not good enough. If you think about, I have a weight and I have a spring, and that's sitting on a table, the spring is going to support that weight, and it could absorb some of that vibration. But if you put that spring on a trampoline, now you don't have a stiff supporting structure to help the spring do its job. Suddenly the spring pushes down, and when it pushes down, it's just got another spring. And if that spring is your floor, that floor now gets all of the energy that the spring was trying to absorb, in a simple term.
So it's actually worse.
Is it worse to put rubber underneath the washing machines? Probably not, just because the resonances are more offset, but I don't think it's going to help in the way that people think. It might deal with a little bit of, if there's like some noise from the like the water rushing, anything that's like high frequency, rubber is pretty decent for that, but I think that's probably not what people are complaining about. I think it's more the spin cycle.
I'd like to thank Nathan Sibon for joining us on Soundproofist. To summarize, we covered some common issues that bother people in apartments and in wood frame buildings, and the concept in acoustics of source, path, and receiver. The most effective way to deal with a noise problem is to tackle it at the source, whether it's a person like your neighbor or if it's coming from a machine. As Nathan said, don't put the loud thing next to the quiet place. If you can't deal with the noise at the source, if the source is beyond your control, the next option is to treat the path. But as Nathan pointed out, that can get very expensive, and most people can't afford to reconstruct their apartments or their buildings. We talked about some of the common things you can do to dampen noise, and they do reduce the noise transmission to some degree. We've covered some of them in the Soundproofist blog, but they won't get rid of it completely. Because the bottom line is, older wood frame construction, especially in the US, is noise conducting. Newer construction with heavier materials like steel or concrete is more successful, and also insulation. And new construction codes that address noise also help. We also talked about some things that won't solve an incoming noise problem, like drapes and sound panels. They won't stop noise from coming into your home from outside, but they might make you sound better inside your home, especially if you're a musician. And finally, we covered how you can change yourself or how you can deal with the noise, especially if you can't stop it from the source or on the path. It might be going into another room, or making an agreement with your neighbor, or using white noise or soft music to mask the noise. Thanks for listening, and be sure to visit the Soundproofist blog at soundproofist.com to learn more about sound and solutions. See you next time.